I think CRISPR-Cas9 has already had a great impact in life sciences in general over the past, I would say, 13 years, because it's a technology that was adopted very, very fast by biologists and developers. The potential to develop further the technology to treat human diseases, focusing first on genetic diseases, came very fast, actually. And after 10 years, it's still, I think, the area where one sees CRISPR the most developed in terms of the technology that is further developed. It's really for the treatment of diseases, but also all the research and development behind using a technology for curing diseases. So there is using the technology directly to cure diseases and indirectly by all the research and development done in academic labs, clinical labs, and pharmaceutical and biotech labs to really bring further the technology to be used to understand the mechanisms of diseases, and to also use the technology to be able to advance the search for new targets for therapeutics and to develop models that models of diseases that allow to test the therapeutics in development. So a lot of research and development behind, let's say, the use of CRISPR-Cas9 to cure diseases. Morega was the first to actually give the name CRISPR-Cas. I think he will say it himself that it was an acronym that was maybe not easy to pronounce, but that ultimately people liked very much. I think his work was really essential at the beginning. This was really, he was among the pioneers who were really digging into the genomes of bacteria. The first pioneers who came to see CRISPR. And Morega was really one of the first to really analyze the genomes, and also with a view of analyzing the genomes based on the diversity of bacteria, because this is what makes CRISPR what it is now, is the diversity of the system in multiple bacterial species. So his work was really essential, and I have to say that in addition to Morega, there were also other pioneers before me, actually, and they paved the way to highlight those defense systems. And me, I was here to have the chance to work on a specific bacterium, Streptococcus pyogenes, to have the chance to work on one of the diverse CRISPR-Cas mechanisms and have the chance to have everything in my hands to understand the mechanism. But prior to understanding the mechanism, there was the groundwork on the genetic aspects of the systems and having identified that these systems exist and what they are genetically speaking and the diversity of the system. When I approached Jennifer Doudna, we had advanced quite a bit on the mechanism already. We had published a paper in Nature describing the first part of the mechanism, and we knew where we were going in the second part of the mechanism, and I was anticipating actually that the system would be used as a genetic tool, and what was important for me was to get the structure of the Cas9 system, because when you use a genetic tool, you want the genetic tool to be as tiny, as small as possible, because this is a tool that will be delivered into cells. So it has to be tiny, to be delivered properly and to have also its impact in the cells. And so with all the diversity of Cas9 systems existing, we were working on one that was not very small, that was in between in terms of sizes. And so I was interested in understanding the structure to try to develop tiny tools in a way. And this is when I approached her. She's a structural biologist, and when ultimately Martin Jinek joined forces with the second part of the mechanism, and this led to the Science article, and together, how do you say, bringing what the technology will be forward, meaning the how to harness the natural Cas9 mechanism into a technology that could be used and adopted by the scientific community right away. So this started with with a need, and this ended up joining forces together to really highlight this beautiful technology. So with regard to the use of the technology beyond the therapeutic need that is human transformism, and this was heavily discussed already 10 years ago in 2015, and I was happy to see a number of national academies writing some statements and reports with regard to their views of how the technology should be used, and to actually literally ban the use and the development of the technology for its potential applications in transforming the human germline. And this first because the technology was not, and I believe is not ready yet to be as precise to be used in this context. And second of all, because of ethical matters. And I joined this community of scientists who thought that before the technology could become potentially interesting in terms of prevention of certain diseases, the technology should not be used for other purposes than around diseases, so curing or potentially preventing. And I still believe this. Unfortunately, in 2018, a scientist in China decided to use the technology, and this was very much criticized. Actually, this led this scientist to go to jail for a period of 2 years, and this was heavily criticized by the scientific community. I trust public institutions doing science to have the regulations in place, at least in most of the countries. Now, one cannot stop, maybe in the future, the use of this technology in the human germline in private laboratories. But this is not what we see now. And I find it interesting because 10 years ago, when I was asked the question, I was a little bit puzzled. I was like saying, I believe it's a bit still science fiction. I don't think that in the next 10 years, one will see the application. De facto, we saw it with one case, at least that has been publicly mentioned. And 10 years later, we see nevertheless that it's not, I would not say that it's not a concern any longer, but I think the technology takes some time to be developed to cure diseases. And I think people see this more as actually an opportunity and more as a challenge, and it's more this that should be discussed. And that the fear of using the technology for human germline, it's not that it's not actual, but it may come, but it's maybe not primary. CRISPR, it's really a technology that tackles the big challenges in a way, health for all, one health for all, and also everything that is with regard to the need of food. It is interesting because it's a technology that allows to produce genetically safe plant crops, in the sense that it's a technology that allows to produce plants that could be seen developed in a natural fashion. So without, at the end of the process, tool applied to modify the plant, at the end of the process, no introduction of foreign DNA, which was maybe the issue with former technologies that were used to modify genetically plants, so the GMOs. CRISPR offers a safe way to produce plants, and it has really opened a lot of perspective in terms of also developing plants that can be better adapted to the challenges of global climate changes. So a lot of research is done behind finding mutations that can allow a plant to resist a certain trait that is drastic in terms of climate change, and to try to see whether this mutation can then be introduced into the plant, so to produce plants that can anticipate the production of crops leading to plants that can resist certain drastic changes. And this, it's very important, because this is actually what we will need to do. And what I found interesting as well is that it allows as well to maybe reproduce plants that were also, we knew were existing in the past. Maybe, let's say, for the public, the image of GMOs ended up to be a little bit, puzzling. But I think CRISPR has to be seen as a technology that is very, very useful to reconsider how plants are produced. And it's not about how plants are produced at the end of the day, it's what kind of plants we're interested in having produced for the benefit of the planet and our own benefit, and the benefit for everyone having access to food. When we know all the challenges of climate change, every day we are confronted to this, and every day we wonder, and I think in Spain, I'm sure that the farmers wonder how they are going to be able to deal continuous production of their vegetables and fruits and so on. So this is really where I believe CRISPR can make the difference. The company CRISPR Therapeutics, which I co-founded with Rutger Novak and Sean Foy, together with Vertex Pharmaceuticals in the US, are working further on the development of the technology beyond genetic disorders, where they could actually develop a cure that was approved by the Food Drug Administration in the US more than 2 years ago, and that was to treat blood genetic disorders, sickle cell diseases and beta thalassemia. This biotech company also, together with Vertex Pharmaceuticals, they also developed further CRISPR also in the areas of cancer diseases and metabolic diseases. We work on other aspects than CRISPR, which I hope are interesting, but I'm always interested in new discovering new pathways or new molecules. And I'm a bacteriologist, microbiologist, and my lab, it's still bacteriology and microbiology. This is my area of expertise, and this is what I feel the most comfortable in terms of research to do. I'm also a geneticist, but more on the bacterial side. I have to say there are always a number of obstacles for a scientist, whether male or female. And for female scientists, maybe they deal with more obstacles, as a matter of fact. I think right now we face more a generational matter in a way, which I think is good in the aspect that what has been an obstacle for female in science was maybe the idea or their fear to not be able to consolidate the familial life with the work life, because being a scientist, it's a lot of work. But this affects also men, as a matter of fact, and this affects specifically the men of the young generation. So what is interesting is that the concerns or the fears that young female scientists had, now the young male scientists have, because in a lot of societies, a lot of young male in general are really investing themselves more in the family, and they want to have more time with their kids. So this I find it interesting, because now what I see personally is that some concern that female scientists will have, male scientists also have, which I think in a way is good. Like, for example, I'm in Germany. They have done a lot to try to raise the number of females in science. And the second aspect is that it's still a world of men, de facto. It's still a lot of men leading. It's just the point. I'm in Germany and it's like this. My experience is that individually, it's never a problem. or rarely a problem, or sometimes a problem, but it could be a problem also with independent of the gender. But brought together, it's logical what I say. Science has been based on a leadership that is more masculine, and that is more based on what men think it's good for them. So it's more a system matter in a way, and a culture matter. And this will take long time before it's changing. And what I fear actually right now, to be honest, it's more the fact that I see that we tend to go back more to the past. So I'm in Germany, for example. I believe they did a lot to try to bring more women in science. But now the young generation is not interested to take leadership positions. In general, men and women. And maybe also, again, young women, because they want to be more close to the family than maybe 10 years ago or 20 years ago. And what we could do, for sure, there is always to try to be honest, independent of gender and independence of anything. It's about bringing confidence to the young kids. At the end of the day, the people who make their way are those who have leadership skills. But it brings people with a certain sensitivity and creativity. And I think these are those boys and girls which we need to bring with, to bring more, to learn about science, to be excited about science, to explain them what science is about, what being a scientist is about, to highlight them, in the spirit of science, and for the young girls to bring them more confidence that this theory that only boys are good in mathematics, etc., and it's wrong. The educational system, it's changing very fast now, so I believe it's also a challenge for the teachers and for the parents as well. The moment when I decided to be a scientist, it's always difficult to go back to the past and know exactly. But I think there were two parts in a way. There was the first part that was just that I like to learn and I was curious. So it's really the curiosity. And I liked the idea to be at the university. I had an older sister whom I could see going to the university when I was a little girl, and I understood that one could be an adult and still continue to learn. And I found this very exciting, actually. Maybe it was a way to not work and to continue to learn. But at the end of the day, I became a very hard worker. The second aspect was just, at the university, being excited by what I could learn, but being more excited by the teacher, actually, whom I could see were teachers doing also research. And I was curious about, they do research, what is it? And very, very fast, I decided to go to labs and pipette and see what it is. And very fast, I realized that actually it's very nice, and I felt very, very much, aligned with what it will be to be a scientist, an intellectual work, then having ideas, concretely going to the bench, doing your experiments, see whether it works. And the different aspects after around science, working in a very solitary manner, but part of a team, being in an international environment. I mean, very fast as well, I identify myself a lot being in this environment, working with people. This is what I tell my students, even my postdoc. What I tell young people often is culture their curiosity in a way. And through this, seeing what they like, what they don't like. Not everyone has to be a scientist, and even not everyone who starts science has to continue to be a scientist. One has to know a lot himself or herself, because being a scientist requires a lot of skills, and not everyone can have these different skills. But interestingly enough, I know people in the public who are so much interested in science and who are actually more educated in science in general than me. Because as scientists, after you become very precise and you know your field and you don't have time to read about other types of science. What I think I tell them is that science is everything. Everything now in the world is based on science, all the innovations. There is always science behind, science at large, human sciences, etc. And that they should be curious about it. Ask questions, why we have a cell phone, why we have this, and what is the science behind? and be interested about this, independent of whether they will become a scientist. Science belongs to everyone in a way. Everyone should be a scientist by just knowing a minimum of science and being excited about it. Then after, there will be some who will become a scientist, some not, but I think the curiosity is the basics. Then after, if you want to become a scientist, you have to know yourself a lot, because it's a lot of being perseverant and lots of work, being resilient, but this is another matter. But I think primarily, and this is what we need to teach the kids actually, is to ask questions, be excited. Then after, the rest follows. People have to find their own way, and it's what I tell them as well. They should, because it's the problem of the young generation, specifically nowadays. They are so much bombarded by information, and they tend to look at those who are extremely successful and to think that it's a fast past, or to think that it's impossible. But they should not look at those who are, they should just look at facts, being excited by what is around them. And then they will find their way, and that is the matter.